Okay, so I'm not even joking. This is seriously one of my favorite lessons ever.
Is it easy?
I think it's easy once you recognize the pattern. Okay? So, every day is fun in here. What are you talking about? So, when you were in Integrated Math 1, you learned how to graph lines, correct? I'm going to go to a separate piece of paper here for a minute. When you were in IM 1, you learned how to graph a line, something like this, yes? Mm-hmm. What do you know about the degree of a line?
0.
Not a 0.
It's 180.
Okay, so this could be an example of the line y equals x. What is the degree there? 1. Okay. When you were in IM 2, you learned how to graph something like this, such as this. Degree what? 2. Over the last couple days, you have learned how to graph something that looks like this, which is degree 3. Now I'm going to show you the pattern that will help you decide what any other polynomial looks like based on its degree. Okay? So here we go. Okay. See if you can notice any patterns here.
I see it.
For every evens, it's both going up. For every odds, it's up and down.
Hold on to that because I want to talk about that in a minute. Okay? Now these are very approximate graphs. I'm kind of exaggerating things.
I see it.
Okay, so let me go back to what you were saying. What did you say about the evens and odds?
Every even is up. Every odds is up and down.
Okay, so he says every even has both ends going up. 2, 4, 6. That is correct. Every even has the sides going up. Now, part of that is because all of these have a leading coefficient that is positive. If my leading coefficient was negative, all of my evens would look like that. So to kind of add to what you're saying, I'm going to say that instead of the evens having the ends going up, the ends are going the same direction. Okay? Because they could be going up or they could be going down depending on some other factors. What else do you know? The odds, you said the ends are going in opposite directions. Up and down for first degree, up and down for third degree, up and down for fifth degree, up and down for seventh degree. Exactly. What else do you notice?
There's more humps.
Like, you can kind of, like, see how you drew it.
How?
Like this squared one, it's going, like, the parabola is number 2, so it goes 1, and then 2, right? And then for 3, it goes 1, 2, and 3.
Okay. Does anyone else have another way of saying that?
1, 2, 3, 4.
Oh, like each time the degree goes up, there's like a curve, one more curve added.
There's one more curve added. Okay.
Every next odd, it goes up, it adds another hump.
Okay. So I'm not going to talk about the bumps. I like to call them bends. Okay? Bends. Okay? Because the most important things that we're going to talk about today are ends and bends. Okay? How many bends does this line have?
0.
0. How many bends does this line have?
1.
How many bends does this line have?
1.
2.
3.
2. There's one here and then one there. How many bends does this one have? 1, 2, 3. What about this one?
4.
So, can you tell me something about the number of bends?
The number of bends.
Every time you go up.
It is increasing, but if I asked you for the y equals x to the 20th, do you really want to have to draw the 19th, the 18th, the 17th, the 16th, the 15th?
21.
There's 21 ends.
It's only one down from the actual number.
Say that one more time.
Oh,
The number of bends is one down from the actual number.
From what actual number?
the degree.
The degree. So the number of bends is one less than the degree. So how many bends would a 17th degree polynomial have? 16 bends. And 17 is odd, so would the ends be going the same direction or opposite directions? Opposite. Okay? So knowing those two pieces of information, you could pretty much sketch approximately, very approximately, what any graph could look like. Do you get that? Because all you have to know is if it's even, what the ends look like, or if it's odd, what the ends look like, and then how many bends there are, which you determine just by one less than the degree. So, that's where we're going with this. So let's come back to our notes page now. Okay. One last thing I want to talk to you about. If you have based on degree and behavior. Okay. If you have even degree with a positive leading coefficient, your ends, well, the way I like to say it is the right side's going up. And on these guys, it's going to be both sides. If you have an even degree with a negative leading coefficient, guess what happens? Ends are going down. What else could I have? I could have a odd degree with a positive leading coefficient. And in that case, you've got ends like that. Right side goes up, left side goes down. And then finally, odd degree with a negative leading coefficient is reversed. Left side goes up, right side goes down. Now, based on the leading coefficient, I will mostly be talking about just the right side. Okay? So all I need to remember is whenever I have a positive leading coefficient, in both of those cases, what's happening to the right side? It's going up. Regardless of the degree, the right side's going up with a positive leading coefficient. With a negative leading coefficient, regardless of if it's even or odd, the right side is going down. So you'll kind of see my line of questioning as we go through this. That's kind of what I just talked about. So let's look at this guy right here. Okay, here is an approximate graph of something. And let's fill out the end behavior first. What do you notice about the end behavior?
They're both going up.
They're both going up. So when it asks me about the right side, it's going up. And the left side, it's also going up. So what does that tell me? If the right side is going up, what does that tell me about the leading coefficient?
It's an even number.
Bless you.
Not necessarily even.
It's positive.
It's positive. And I determined it's positive because the right side is going up. Because both sides are going up, because both sides are going the same direction, what does that tell me about the degree?
The degree can be an even number.
It's even because both ends are going the same way. Do you have a question? Yeah. Okay. You were just looking at me like you had a question. So because the right side's going up, that tells me the leading coefficient is positive. Because both sides are going the same direction, that tells me it's even. And I could actually approximate what degree this is by counting the bends, couldn't I?
Sure.
1, 2, 3, 4, 5,
6.
So if there's 5 bends, it is going to be, now watch how I write this. At least a 6th degree. Why did I write at least? Because if there's any teeny tiny bends in there that I can't see with my naked eye, I'd have to actually look at the computer graph of that. If there's any teeny tiny bends in there, it would only make the degree go higher because it would be adding to the number of bends, right? That's why I put at least 6, because from what I can clearly see, it's at least a 6th degree. Please never, ever, ever tell me it's an even degree and then tell me it's at least a 5th degree. Don't ever tell me it's an even degree and then say at least 5th. Because 5th isn't even. Doesn't make sense. Okay? All right, tell me about what your domain would be here. All real numbers. What about your range? There's a distinct bottom point, isn't there? So it would be y is greater than or equal to whatever that lowest point is, right? So I'm going to put minimum value because I can't be any more specific than that unless they gave me some grid lines to show me what they were counting by. Does that make sense? If they told me, oh, that's negative 20, then I could say y is greater than or equal to negative 20. But because they don't, I'm kind of stuck with that. Capiche? All right, let's look at this guy. What's going on the right side? Positive infinity on the x, that tells me about the right side. What's going on the right side? It's going up. What does that tell me about the leading coefficient? It is positive. Right side going up makes a positive leading coefficient. What's going on the left side? It's going down, so I'm going to put negative infinity there. And what does that tell me about the degree if the left side is going opposite the right side? Odd. Odd has opposite ends. If that's helpful, good. If not, just laugh and be done. Okay, how many bends are there?
2. So it's 3.
2. So it is at least a 3rd degree. And again, why do I say at least? Because this bend isn't quite as pretty as that one. There could be some teeny tiny bends in there that I can't see. And if there are, it would just make it higher than a 3rd degree. What would you say about your domain?
All real numbers.
What about your range? Huh. We talked about our cubics having all real numbers for both domain and range, right?
Yeah.
Would that change for any other odd degrees? So every odd degree polynomial is going to have a domain and a range both of all real numbers. What about every even one?
The minimum value of the...
Every even one will have a domain of all real numbers, but the range will either be y is greater than whatever that minimum value is, or if it's upside down, y is less than whatever that minimum value is. Yes. All right, so let's look at this guy. What's going on the right side?
It's going down.
So I put negative infinity there. What does that tell me about the leading coefficient?
It's negative.
Okay. Left side is going where? Up, so that's positive infinity. What does that tell me about the degree?
It's at least...
It's odd because it's going the opposite direction, right? What would I say specifically about the degree?
It's at least 3.
At least 3. You could even argue at least 5th or 7th even. Why?
Because there's more to the...
Because these bends are not nice bends. There's probably like 1, 2, 3 in there that we just can't see. Do you get that?
Yeah.
But I just kind of take the big bend and say, you know what, I'm just going to cover all my bases and say it's at least a 3rd degree and be good there. Again, if you're telling me it's an odd degree, don't tell me it's at least a 4th degree. or at least a second. What's my domain? All real numbers. And what's my range? There we go. So that's half of what you need to know to be able to do. Think you can handle that? Could you hand me one of the homework worksheets, please? Yep. Now, on your homework, on the back side of your homework, there's a bunch of graphs given to you. And it asks you about the leading coefficient, positive or negative. Well, this one, since the right side's going down, what does that tell me about the leading coefficient? Negative, so circle negative. The degree, is it odd or even? Well, if the left side's going opposite, that makes it odd. The least degree, that's where you're going to count your bends. There's 4 bends, so it's at least a 5th degree. Then you're going to talk about your end behavior. Now, I apologize on this worksheet. We didn't write this part for you.
Okay.
And x approaches negative infinity, y approaches. We forgot to fill that in for you. On the test, we fill that in for you, so you just have to put the infinities at the end. So you'll have to do this. Right side's going down, left side's going up. Domain, estimated range. Why is it estimated range? Well, because when you're given a graph, like here, I would say y is greater than or equal to 0 as my range. But it's just estimated because I can't really see that closely to see if it actually does make it all the way down to 0. Okay? So that's what estimated range means. Now, on the top 2 problems, for some reason, the copier cut off the lead coefficient thing. So just tell me positive or negative up here, since you can't really circle the line. That makes sense? So that's the back side. Those should go pretty quick if you know what you're doing, right? Now we got to talk about the front side. And that's what these problems are like down here. All right? So, what do I know about the leading coefficient of this polynomial? It is positive. Right now, I don't care what the number is. I just care whether it's positive or negative. Because what does that tell me about the right side of my graph? It's going up. So I'm actually going to draw an arrow going up for the right side of my graph. Because I have to sketch it. What is the degree of this? Third, which is odd. So what does that tell me about the left side of my graph? It's going to be going the opposite direction. So do you see how I have my ends there? The ends, and now I have to fill in the bends. Third degree means I need how many bends? 1, 2. So connect your ends, and there's your sketch. Yep.
This is fun.
I told you it was fun.
Oh my god. Wait, so we don't...
You don't need an X, Y axis. I just want to know where the end's going and how many bends have you got.
And that's it?
For these ones, yeah.
Oh.
Okay, right here. What is my leading coefficient?
1.
Negative. Again, I don't really care what the value is as long as I know whether it's positive or negative. What does that tell me about the right side?
It's going down.
Down. What is the degree? 4th, which is... So what does that tell me about the left side? It's also going down, and the 4th degree tells me how many bends? So I'm going to connect my ends with 3 bends. 1, 2, 3. You want to try the last one?
Sure.
Live dangerously. Go for it. Isn't this fun?
Yeah.
My leading coefficient is... What does that tell me about the right side? Down. Degree? Which is what? What does that tell me about the left side? It's going opposite. Odd is opposite sides. How many bends do I need? 1, 2, 3, 4. And I should have a graph that looks something like that. Okay. Couple things. When it says what's the degree, I do need two things. I need both the number and then also state whether it's odd or even. Okay? Because one of those tells me about an end behavior and one of those tells me about the number of bends that I'm counting. All right? So on these guys, all you're going to be doing is, based on the leading coefficient and the degree, sketching what it should look like, right? Find the leading coefficient and the degree, odd or even, and degree number. End behavior, sketch the graph of each function. You don't need x and y axis, you just need to sketch something like this. Okay? Then the last two, we tried to be a little tricky. Just write it in standard form first and then sketch it. Okay? And then the backside's just the circling stuff. Good deal? All right. Happy studying.